All right, we're going to start our second week of trig, okay, and this is going to be on what we call unit circle trigonometry. So you have any idea what shape it's going to have to do with?
A square, I think.
A square. Yep, it's going to have, no. So yeah, we're going to deal with circles, and we're also going to deal with triangles. We always, generally triangles are tied into it somehow because it is trig. So. All right, so let's look at this diagram. And I'm going to try to explain to you what the goal of unit circle trig is. So what I've drawn here is a unit circle. A unit circle just means that it has a certain size to it. Specifically, the radius is 1. Okay, that's what a unit circle is. Circle with a radius of 1. And now, let's draw an angle inside that circle. Remember, an angle has two sides. One side is the initial. The other side is the, anyone remember that name? The initial side, and then the, what's the other side of the angle called? Begins with a T. Yeah? Terminal, yep, very good. So, initial, always going to look something like that. Terminal, let's say it goes like that. When you draw that terminal side, it hits the edge of the circle somewhere. Okay, no matter where you put the terminal side, if you keep extending it, eventually it hits the perimeter of the circle. The whole goal of unit circle trig is to figure out the location for where the terminal side hits the circle. That's the goal, to figure out that coordinate in green. What that coordinate does is it basically gives us a location on the circle. It's a location that corresponds to an angle of that size. Okay. We don't know what size that angle is. Maybe it's 50 degrees. Okay. Let's say it's 50. So if that's a 50-degree angle, if we can figure out that coordinate, which is the location where the terminal side of a 50-degree angle hits the circle, then we can do some things with that angle that we're going to want to be able to do. But we have to know that coordinate to do it. Okay? That's the whole goal of unit circle trig. Each angle has a unique coordinate between 0 and 360. So if I draw, let's say, a 20-degree angle, something like that, that's going to have a different coordinate than a 50-degree angle because the terminal side is a little bit lower. So every angle between 0 and 360 has a unique coordinate. When you go past 360, then you start repeating. Okay. For example, 0 degrees has a coordinate right there. What other angle would also have the same coordinate as 0 degrees? Yep.
180.
Nope, 180 is over here. So 0 is on the right, 180 is on the left side. Yep.
360.
But 360, yep. 360 and 0 have the exact same coordinate. Yep. All right. So let's write that down. So angles that are, it says angles that are multiples of 30 and 60 degrees. Those are the ones we're going to work with. Angles that are multiples of 30 and 60 degrees can be represented as coordinates on the unit circle. And actually, you know what? I'm going to add, I'm going to fix that. It should say, because if you're a multiple of 60, you're automatically a multiple of 30. It's kind of a repeat. So I'm going to say it like that because that's more accurate. Angles that are multiples of 30 and 45 can be represented as coordinates on the circle. Now, technically, you can do other angles besides 30s and 45s. You can do like 15s, but in this class, we don't do that. So when we're doing unit circle trig, the kind of angles that you're going to be working with, 30, 60, 90, 120, 150, 180, 210, 240, anything that's a multiple of 30. Okay. And there is some overlap with multiples of 45. 45, 90, 135, 180, 225, what else? 270, 315. Okay. And again, there's like 90 is a multiple of both. Okay. So that's the first step, to understand what kind of angles you're going to work with when you're doing unit circle trig. We are just working with angles that are multiples of 30 and 45. So if you wanted to find the coordinate of like 12.7 degrees, where that hits the edge of the circle, that is not something you use unit circle trig to do. Okay, that's not what we're doing. Okay, so there are two directions that we can move on the circle. We can go clockwise or we can go counterclockwise. Depending on which way we go is going to control the difference between working with a positive angle and a negative angle. If you move in a counterclockwise direction, okay, that is a positive angle. And let me show you guys an example. All right. So we said counterclockwise gives you a positive angle. So if I move this right there to 30 degrees, I get a positive angle. If I go in if I tell you you're working with a negative angle, like negative 90. Negative 90 would be drawn just like that. And you do have to know how to draw it, because then the goal would be, what is the coordinate for negative 90? We're going to talk about the coordinates for 0, 90, 180, and 270 in a minute. Now, when you are dealing with triangles, we really don't talk about negative angles. Because triangles, you're not really talking about rotation. Right? On a circle, you are. So that's why we use negative, just to represent a different direction. That's all the negative means, it's direction. Triangles don't really have direction. They're lost. They have no direction. All right, so let's look at labeling those four angles that I just mentioned: 0, 90, 180, and 270. So let me go back up to this diagram. I'm just going to erase that so it doesn't look as busy. And let's start with the coordinate for 0 degrees. So this is the origin right here. That's not on the circle. That's 0, 0. What did we say the radius is for that circle? 1. So knowing that the radius is 1, anybody think they know the coordinate for 0 degrees? Yep.
Is it 1, 0?
Yep, it's 1, 0. That is the location on the unit circle that represents the 0 degree angle. That's the coordinate for it, 1, 0. Okay. How about 90 degrees? Anyone think they know that coordinate?
0, 1.
Yep, 0, 1. And that never changes. That is always the location of a 90 degree angle on a unit circle. Right. How about the coordinate that would represent 180 degrees?
-1, 0.
Yep. Okay, so there's your coordinate for 180. And how about the coordinate that would represent a 270 degree angle?
0, -1.
0, -1. Okay, those four angles are the easiest coordinates that we're going to work with all week. Okay, there's no fractions in them, there's no decimals, and they're all ones, zeros, or -1s. And remember, the first letter is the X, and the second letter is the Y. Okay, if you switch the order, that messes everything up. So you got to know the order of the letters. All right. So now I said once you go past 360, you start repeating angles. All right. So like if I did this, that's 450 degrees. Right? 450 degrees is kind of a bigger angle to work with. We don't really want to work with an angle that big. It can make it hard to know the coordinate. But 450 is the same as another angle we just talked about. What angle that's smaller is exactly the same as 450? And when I say the same, I mean this little red circle would land right at the top, just like it is now.
90.
Yes, 450 has the exact same coordinate as 90. Okay. Does anybody see what you can do to 450 degrees to change it into 90? Think about what I just did on that picture to put this, when it was at 450, what I did to make it 90. Yeah?
Divided by 5.
Okay, so let's say we had an angle that was at 360. We know that's the same as 0, right? But if you take 360 and divide by 5, it wouldn't give you 0. So it wouldn't be dividing by 5, but it's a different operation. Yeah?
You took away 360.
I took away 360. Right? I have an angle over here, like 540 off the top of your head. You might have a hard time visualizing it because that angle is big. But if you subtract 360 from it, subtract 1 revolution, you get an angle that's smaller, and you get an angle that you should know the coordinate of. So that's a trick that we can use to work with angles that are too big. Okay? So if you have an angle that is bigger than 360, you're going to subtract 360 as many times as you need to until you get it small enough. You don't want to subtract 360 too many times, because what would happen if you subtract 360 too many times? What kind of angle would you end up with? Yeah? Yeah, if you do it too many times, you're going to make it negative. We don't want that either. So we generally like to work with angles between 0 and 360. So then, what do you think you could do if you had a negative angle, like that, and you don't want to work with the negative? You want to convert that into an angle that's positive and a little bit easier to think about. What could we do in this case? Yeah? Yeah, we could add 360. And if you add 360 to negative 90, you get 270. Okay. So you can add or subtract 360 degrees as many times as you want, and that will not mess up the coordinate. Okay. All right, so any questions on that? Okay, so now let me show you what that means when we're working on a calculator. Okay. For now, we're not using the calculator. But let me take the cosine. Again, we might not know what that is yet, but that's okay. Cosine of 30 degrees comes out to that number. If I add 360 to 30, what do I get?
390.
I get 390. How do those two answers compare?
They're the same.
They're the same. So when you are doing trig, which means you're pressing one of these 3 buttons, sine, cosine, tangent, adding or subtracting 360 to the number that you put inside there will never change the answer. Right? So if I do like the sine of 10, that's the answer I get. Okay, don't worry about how it gets it, but that's what you got. What number could I put inside there that would give me the same answer? I could put in 370. Yep, I could add 360. Okay. I could also add 360 again. And I could do it again and again and again. Anytime you add or subtract any multiple of 360, it's not going to change the answer when you do trig. Okay? I'm not saying that the number 10 and the number 370 are the same number. I'm saying when you plug them into a trig formula, you'll get the same answer. Because they're the same coordinate in the circle. That's the reason why. All right. Any questions on those two steps? Okay. So what we need to do now is look at what are the 6 trig functions. Okay, I kind of showed you a couple of them when I pressed some buttons on here, which we're not doing yet, but sine and cosine are a couple of them. Okay, I'm going to show you all 6. And the way that we're going to define the functions, it's all going to be based off of an x value and a y value. So if you can't figure out the location for the angle that you are working with, then you're not going to be able to do unit circle trig. Okay, you have to be able to figure out these coordinates. And right now, I've only shown you how to find 4 of them. 0, 90, 180, and 270. Okay, during the week, I'm going to show you how to do some of the others. So these are going to be the 6 trig functions defined using a coordinate on a circle, specifically a unit circle. And the first 3 trig functions we'll start with are sine, cosine, and tangent. There's 6 main trig functions that we study throughout the year. Just like we've done other functions throughout the year. We studied the log function. We studied square root functions. We studied quadratic functions, radical functions. Well, these are trig functions. Okay, first thing to understand about a trig function is when you type it in on a calculator like this, sine, and you put in a number, that number that you just put in is an angle. Where would you have gotten that angle from? Maybe you had a diagram of a triangle, and that's where you got the 15 from? I don't know. But wherever you got it from, that number is an angle. So trig functions have to do with angles. That's the number you plug in. Each trig function has a 3-letter abbreviation, which most of the time when we write it down, that's the abbreviation I'm going to use from now on. Okay. So sine is abbreviated SIN, cosine, COS, tangent, TAN. Calculator uses those same abbreviations. And here are the definitions of how you find those trig functions. If you want to know the sine of an angle, the first step is to find the coordinate for that angle. And if you want the sine, it specifically is the y value of the coordinate. If you want to know the cosine of an angle, find the coordinate for it, and then the answer for the cosine is the x value. If you want to know the tangent of an angle, the formula for that, find the coordinate, then take the y value and divide by the x value. So for tangent, you need both. Sine and cosine, you only need one part of the coordinate. So let's try that with 90 degrees. Okay, so think about where 90 degrees is for a second. What's the coordinate for 90 degrees? 0, 1. So now, let's say that I wanted to type in the sine of 90 degrees. What part of the coordinate does that formula say you need to calculate the sine? You need the y. For 90 degrees, what is the y value? 1. So when you hit enter, that's why you get 1. Okay. If I wanted to do the cosine of 90 degrees, what part of the coordinate do I need for that? I need the x. What's the x value in the coordinate for 90 degrees? The x value is 0, and that's why you get 0. Okay, I'm not going to go through all of them, but that's how you get those numbers. Okay, so those are the first three: sine, cosine, tangent. These are the last three: cosecant, secant, and cotangent. Generally, when you have a trig function, the abbreviation is just the first three letters. But with cosecant, they didn't do that. How come?
It would have been COS, which is the same as cosine.
Yeah, we've already used those first three letters somewhere else. So they just did it by syllable. Cosecant, CSC. Okay, I'm going to show you the first one. And then I think once I do that one, you'll know the formulas for the other two. That's the formula for the cosecant. What do you call, if you compare that to that? Those two things are, there's a word that describes them. Yep, reciprocals. Okay. Each trig function has a reciprocal. And the way that I've put them on the board, I put them in the same row. Okay. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. So are tangent and cotangent. That means once you have the answer to the three on the left, all you have to do is take each one of them, think of y as a fraction, y over 1. Take each one of the ones on the left, flip them, and you get the ones on the right. That's all that the ones on the right are, reciprocals. So based on that, if you want to think of cosine as a fraction, you can always put it over 1. What do you think the definition of the secant is?
1 over x.
Yep, the secant is 1 over x. And how about the cotangent?
X over y.
X over y. Yep. So those are the 6 trig functions. And there is a trick to trying to remember the ones on the left. Does anybody know the word? It's like PEMDAS, but that's for something else. You may know the trick to remember. So the trick, has anybody seen this before? Sakatoa? Yeah. So sine is opposite over hypotenuse. If you've seen that before, that's right triangle trig. Okay, it's a little bit different than what we're doing. All right, but it's still kind of the same idea. All right. If I draw a picture and kind of connect it to that, if you're used to seeing that. Let me draw a triangle just like I had at the beginning. And let me put an angle right there. How long is this side in my circle? It's the radius, and we're dealing with a very specific size circle this week. 1. I don't know the bottom, and I don't know the height. Okay, but sine is opposite over hypotenuse. Look at this triangle. Look at that angle right there. What side is opposite my angle? Y. Sine is opposite over hypotenuse. What's my hypotenuse in that picture? 1. Sine is y over 1, and that's exactly what I just showed you. Okay? So let's try cosine. Cosine is adjacent over hypotenuse. What side is adjacent to this angle? x. Adjacent means right next to. Cosine is adjacent over, what's the hypotenuse? 1. Cosine is adjacent over hypotenuse, which is x over 1, and that's what I just showed you. Okay, so thinking about it this way is a little bit different. It's not really the focus of this week, but what I'm trying to show you is if you know SOHCAHTOA, then you've already kind of done this in a way. You didn't think of it as a coordinate, you thought of it as opposites and hypotenuse and adjacents. But it really is the same thing we're doing right now. But the important thing is, however you can memorize it, those are the 6 trig functions you need to know. Sine through cotangent. Now, the 4 angles that we've talked about already, 0, 90, 180, and 270, those are called quadrantal angles because they land on the axes. And the axes break everything up into quadrants. Okay, as I said earlier, those are the easiest angles. Well, those are the easiest coordinates that we're going to work with all week. The coordinates all have 0s, 1s, and -1s. From there, the coordinates get a little harder. But the nice thing with unit circle trig is, remember, we're only working with angles that are multiples of what? 30 and 45. So there's not that many angles besides those 4 that we're going to work with. There's 3 in each other quadrant. The 30, the 45, and the 60. So there's only 3 in each quadrant. And they're all kind of reflections of each other. So once you know how to do the first quadrant with unit circle trig, you can kind of reflect it into the second quadrant. And all the coordinates are very, very similar. So there's really only, besides the 4 coordinates I just showed you here, there's only really 3 other coordinates you need to know to do all of unit circle trig. There's 3 more. Okay, so how do we do unit circle trig? The very first step is find the coordinate. Sometimes they'll give you the coordinate. If they give you the coordinate, great. Step 1's already done. What would a problem look like where they give you the coordinate? It would look like that. It would say, let P be a point on the unit circle, and they gave you the coordinate up above. What would a problem look like where they don't give you the coordinate? It would look like that. Find the 6 trig functions of 90 degrees. Okay, but either I don't give you the coordinate, or I do give it to you. That's those are the only 2 cases you're going to have. If I don't give it to you, it is your job to figure it out. Now, for today, I've only taught you how to find the coordinate for 4 angles. 0, 90, 180, 270. In tonight's homework, you will not have an angle other than those 4 that you have to figure out. Tomorrow and Wednesday, yes, we're going to do the other 30s and 45s. Okay, so step 1, find the coordinate. Step 2, once you have the coordinate, you're going to have an x and a y value. That x and y value represents the location of where the terminal side hits the circle. You use those x and y values to find the 6 trig functions. Which one of the 6? We're going to practice all 6, okay, in the problems we do. But you take your x and your y value from the coordinate in step 1, and you fill the x and the y value in to all 6 of those formulas. On the test, I'm just going to ask you for one of the trig functions per problem. You'll see all the trig functions on the test. But per problem, I'm just going to ask you for one trig function. And when we go through a problem, I'll show you what I would ask you. Generally, a question on unit circle trig is either going to have one part or two parts. Problem like that would have one part, because I've already given you the coordinate, and I'm going to ask you to do one thing with it. A problem like that would have two parts. I have not given you the coordinate. So the first thing I would do is part A would be tell me the coordinate for 90 degrees. Part B would be one of these 6 questions on the board. Okay. Everybody have those 2 steps? All right, so now let's try to do a unit circle trig problem where I give you the coordinate to start. So let's look at that coordinate. That coordinate represents some angle on the circle. So it represents somebody drew an angle, they drew the terminal side, it hit the edge of the circle, and they wrote down the coordinate where. Now, does that coordinate look like any of the coordinates for the 0, 90, 180, or 270? What do you think? Ricky? No. It doesn't look like the coordinates for 0, 90, 180, or 270. Those coordinates had ones, negative ones, and zeros. This one's got a square root there. Okay. That is not the coordinate for 0, 90, 180, or 270. It's not important what it's the coordinate for. You don't need to know that. By Wednesday, you'll know. That's a common coordinate. That'll come up. But for now, you just have to know somebody had a diagram, they had a circle, they drew an angle like this, and they marked that coordinate right there, and that's about what they got. Negative, positive. Okay. So what I want to do is find the 6 trig functions of that angle right there. And in order to find the 6 trig functions of that angle, you need to know the coordinate. You need to know the location of that angle. And we do. That's the location that represents the angle they want us to work with. Again, how big is that angle? Don't care. Never care about how big it is. We care about where it is. And that's what they've given us. Okay. That's the x. That's the y. All right, so let's start with the sine. What is the formula for sine? It's what?
Y.
Y. Yep, and what's the y value in this case? Yep, exactly. These answers are always exact. Okay, so you are not going to round that up. So that's the sine of this angle. The answer is square root 3 over 2. Okay, let's do the cosine of the angle. In order to do the cosine of it, we need to know where the angle is. That's where the angle is. What part of the coordinate do we use for the cosine?
X.
We use the x. So that is negative 1/2. Okay, now let's do the tangent. What's our formula for tangent? It's y over x. Well, you just did y here, and you just did x there. So just imagine putting like a fraction line in right there. Y over x. We're going to divide those two. What's going to cancel out when we divide those two fractions?
2.
The 2. Anytime you divide fractions and the denominators are the same, the denominators cancel out. So the 2's, don't cross it out because we still need those other answers. But the 2's would basically be gone. And what would be left in the top?
Square root of 3 divided by -1.
Square root of 3 would be left in the top. And yeah, what's left in the bottom? Yeah, negative -1. So really, I mean, you could just, you write your answer like that if you want. Or you don't even need to put divided by 1, because dividing by 1 doesn't change it. You need the negative. That's important. So the answer is negative square root of 3. Okay. So now, once we figured out the 3 on the left, all we have to do is take each one of them, do something, and we'll have the 3 on the right. Does anybody remember what we have to do to each one of those answers? Flip them. Yep. So let's start with the first one. Okay, that's what we get when we flip it. But this happens a lot with unit circle trig. That is a problem. Okay, we didn't do anything wrong, but we can't leave that. Why can't I leave that?
Denominator is a square root.
Right, we don't leave irrational numbers in the denominator. So to fix that, we can multiply the top and the bottom by the same thing, because as long as you multiply the top and the bottom of a fraction by the same thing, it doesn't mess up the fraction. And now multiply straight across. What would you get in the top if you multiply straight across?
2 times square root.
You get 2 times the square root of 3. And in the bottom, you get the square root of 3 times the square root of 3. That's the square root of 9 when you put them together.
So 3.
So 3. That is how you need to write your final answer. 2 square root 3 over 3. All right, let's do our secant. So I'm going to take the cosine, and what am I going to do with that fraction? Flip it. What do we get when we flip it?
2 -1.
Yep, 2 over -1, so we really could just put -2. Okay, and now let's do our cotangent. Can someone explain, how do you get cotangent?
X over y.
Okay, which is really, can you relate it to one we've already done?
Flip the tangent.
Just flip the tangent. Yeah, we've already done the tangent, so just flip that, and you'll get your cotangent. Felicity, what do I get when I flip that? -1 over the square root of 3. And now, anyone think they could tell me what that would be when you fix it so the square root's not in the bottom? Yep.
-1 square root of 3.
So what would be your final answer in the top?
Negative square root of 3.
Yep. Negative square root of 3
Over 3.
over 3. Perfect. And those are the 6 trig functions of this angle, which we don't even know how big it is, but we did know where it was, and that's what was important. Okay. Any questions on that? All right, let's try another one where I give you the coordinate. So this time it says find the 6 trig functions of the angle represented by that location. It's root 2 over 2, comma, root 2 over 2. What do you notice about the x and the y this time?
The exact same.
They're the same. So does that give anybody a hint? We don't need to know this yet, but does anybody think they would know how big that angle would be? Another hint is, what quadrant is that point in? Yeah,
The first quadrant.
it's in the first quadrant, and angles in the first quadrant are between what and what?
0 and 9.
Yeah, so it's between 0 and 90. And the x and the y are exactly the same. Yeah?
Why just be 0?
No, we already know the coordinate for 0. What's the coordinate for 0?
That's 1.
1, 0. Yeah. So it's definitely, it's not the coordinate for 0. Anyone else have an idea? Yep.
45.
Yep. That is the coordinate for a 45-degree angle. We don't need to know that it's the coordinate for 45 yet, but you will tomorrow. For now, we know the location, and that's all we need. All right. So let's start with the sine. Jada, what's going to be my sine of the angle represented by that coordinate? What is it? 10? No, what it's going to be a number.
Oh, is it a number?
Yeah, what's the sine of my angle represented by that coordinate? Well, what's the definition of sine? Yeah, like we wrote down the other page, which says sine equals. We wrote down all 6 of them.
Yeah. A cosine?
No, it's a letter. Yeah, sine, it's a single letter. Okay, help her out. What's sine equal to? Yep,
Y.
sine is the y. Yep. And what's my y value in that problem? Yeah,
Square root of 2 over 2.
square root of 2 over 2. Okay. Now, just because they're the same, can you tell me which one you picked, the first one or the second one?
What?
Which one did you pick?
The right one.
Yeah. Okay. Even if you mix them up this time, you get lucky because they're the same, but in general, you can't mix them up. All right. How about let's do cosine. Jad, what's my cosine going to be? Well, what's the definition of cosine?
For a friend.
All right, Lewis, can you help him out? What's the definition of cosine?
Okay, so cosine is 1 over x.
Okay.
That's the wrong one? Hold on. Oh, it is x. I was thinking of something else.
So what's the definition of cosine?
S.
What is it?
S.
S?
I said x, I said x.
Oh my god.
Look up.
Okay, I'm looking.
Yeah, S is not a valid option for this lesson.
X.
So X.
X.
Okay, so what's my X value in this case?
That was so funny, bro.
Dude, they're the same. It
Oh.
doesn't even matter which one you pick, they're
Oh,
the
it's
exact
the
same
it's
thing.
the square root of 2 over 2.
Square root of 2
Over 2.
over 2. Okay, so that's my X. All right, now let's do a harder one, the tangent. What's the tangent? We got to divide this time. But think about what you're dividing. You're dividing y by x. Yep.
Y over X.
Yep. So when you divide y by x, what do you get?
Y by X. Would it be 1 over 1?
Yeah, it would just be 1.
Yeah.
Because y is root 2 over 2, x is root 2 over 2. When you divide two things that are the same, you get 1. So let's do the cotangent, because that one's going to be real quick. The tangent is 1. What's the cotangent?
1.
It's also 1, because when you flip 1, you get 1. There's 2 numbers you can flip and they stay the same. That's one of them. There's one of them. Okay, so you flip 1, you get 1. How about cosecant? What's going to be my first step to finding the cosecant? Yep.
Flip the y.
Yeah, we're going to flip the y. We already know the y is root 2 over 2. What's your first step when you flip it?
You have to
Put 2 on top and square root 2 on the bottom.
Okay, so we get 2 over root 2. Okay, now the trick part's done. Now you got to do some arithmetic and fix that. Okay, we can't leave the square root in the bottom. So I need to, Connor, what would I need to do to fix the square root in the bottom?
Multiply the top and the bottom by
square root of 2.
Yeah, perfect. Multiply the top and the bottom by square root of 2. And what would that give me in the top?
Just 2. Oh no. 2 times square root of 2.
2 times the square root of 2. And in the bottom?
2.
2. And now you have 2 root 2 over 2. What happens there?
You can simplify it down.
Yep, what would it simplify to?
Square root 2 over 1.
Yeah, just square root of 2 over 1, just even square root of 2. So when you flip root 2 over 2, you get root 2. So now, what's my secant going to be?
Square root of 2.
It's going to be the same thing because the sine and the cosine were the same thing. And there's the 6 trig functions, technically of 45 degrees. You don't need to know that it's 45. But it's the 6 trig functions of that coordinate, which represents 45. Any question on that one? All right, so that's the kind of problem where I give you the coordinate and you got to figure out the 6 trig functions. Let's try one where I don't. So now I'm asking you for the 6 trig functions of 90 degrees. In order to do any of those 6, what's the first thing that we need to know? Yep.
It was on the circle.
Right, we got to know where the terminal side of 90 degrees would hit the edge of the circle. If you can't figure that out, you can't do unit circle trig. Okay. So think about where 90 degrees is. You can draw a little sketch if you need it. And what is the coordinate for 90 degrees? Yep.
0.
0, 1. Now this problem is at the same step as the last two. Take your coordinate and fill it in. Okay, let's start with the sign. Jada, what's my sign going to be?
1.
Yes, because it's my y value. What's my cosine going to be, Chad?
1.
What's the definition of cosine?
Oh, it's X.
S. No, it's x.
That's right.
So it's x. And what's that? What's the x value here?
0.
0. Good job. Okay. My tangent. Okay. What's the formula for tangent? Yep. Y over x. So in this case, it's what over what?
1 over 0.
It's 1 over 0. We've got to write down what that is. What do you get if you do 1 divided by 0?
0.
That would be 0 divided by
Oh,
1.
You can't divide it by 0.
Can't divide by 0. So we say undefined. The tangent of 90 is undefined. Can't do that one. It says undefined. Okay. So now we're going to take all of those and we're going to do what with them to get the 3 on the right? Flip them. Okay. What do you get if you flip 1?
1.
Stays the same. Now you might think, how do you flip 0? It's not a fraction. Okay, make it a fraction. 0 is 0 over 1. What do you get if you flip 0 over 1?
So undefined.
Undefined. 0 over 1, when you flip it, becomes 1 over 0, and we just talked about that. So when you flip 0, you get undefined. How about when you flip undefined?
It is 0.
You get 0. Okay? Because this is 1 over 0. That's undefined. When you flip it, it becomes 0 over 1. 0 over 1 is 0. Okay? So a number divided by 0 spells no. You can't do a number divided by 0. No. Don't do it. No. So no means you can't do it. It's undefined. Okay. All right. Any questions on your 6 trig functions there? All right. Let's try just the sine, cosine, and tangent of 3 pi. Okay. What is that? 3 pi. It's an angle. Yes. It's just like that problem. It's an angle. But what's the difference with how I gave you the angle? It's in radians. Okay. Ultimately, what is it that you need to figure out to do unit circle trig? Yeah, you need the coordinate. Okay, you need the coordinate. It doesn't matter how they give you the angle. You've got to figure out the location of it somehow. So what would make, if you're not comfortable working with radians, what would make 3 pi a little easier to work with?
Turning it into an angle,
Well, that is an angle.
or we'll turn it into degrees.
Yeah, turning it into a different unit, okay, like degrees. What do we multiply by to change radians to degrees? Yep. 180 over pi. So the pi's are going to cancel. And what's 180 times 3? Or think of 18 times 3 and put a 0. Yep, that's 540. Okay. Is 540 an angle that I drew at the beginning of class on the diagram? I didn't draw 540. Why not? It's more than 360. So what we want to do now is make that angle easier to work with, and hopefully we'll recognize what it is. Okay. How can I make 540 more recognizable?
Subtract 360.
Subtract 360. That's 180. Is that an angle we talked about on the diagram? Yes, it is.
Yep.
So if you draw 180, put your coordinate, make a quick sketch, you should be able to get the coordinate for 180. Okay. What is the coordinate for 180?
-1, 0.
-1, 0. Yep. Now, I'm not going to say that 180 degrees equals -1, 0, because these are different things. This is the location of the angle. This is the size of the angle. The location and the size are not equal to each other. They're different. But the location is what we need, not the size. All right, so now let's do our sine, cosine, and tangent. Dylan, what would the sine of 3 pi be?
Zero.
Yep, so the sine would be 0. Okay, my cosine of 3 pi? What would that be? Yep, -1, that's the x value. And what about my tangent of 3 pi? 0 over -1, which is 0. Yeah. And you could flip them undefined, -1, undefined, to get the other 3. Okay. Any questions on that? Let's try one more. So find the 6 trig functions of 11 pi over 2. Okay. What have they given me in this problem? Yeah, they've given me an angle. That's not what I need to do unit circle trig. I need to know I have to figure out the coordinate. So what could we do with that to help us to start figure out the coordinate? Yep.
Convert it to
Okay, we could convert it into degrees by multiplying by 180 over pi. And then 2 goes into itself once. How many times does 2 go into 180? 90. What's 11 times 90? 990. Okay, so we've got our angle in degrees now. Why is that angle still kind of hard to think about the coordinate? It's not an easy angle to work with, 990. Yeah? It's over 360. So we need to do what to it so it's easier to work with? Okay, so I'm going to subtract 360, and I get 630.
Try it again.
Do it again. Now I get 270. Would I want to do it again?
No.
No. If I do it again, it's gonna go negative. Okay, so we got 270 degrees. Think about where 270 is. Where's 270 on the circle?
The bottom.
The bottom.
-1.
Straight down. What's the coordinate
Come so fast.
when we go straight down? 0, -1. Yep. Now we can do all our trig functions. What's the sine of 11 pi over 2? -1. What's the cosine of 11 pi over 2? 0. And the tangent?
1 over, -1 over 0.
-1 over 0, which is
Undefined.
undefined. Okay, the cosecant of 11 pi over 2?
1 over -1.
And what is that reduced to? 1 over -1.
-1.
Just -1. Yep. How about my secant?
1 over 0.
It would be 1 divided by 0, which is
Undefined.
undefined. Okay, and what about my cotangent?
0.
That would be 0. Yep. Okay, so that's basically how we do unit circle trig, where you have to figure out coordinate of one of the quadrantal angles. Okay, tomorrow we'll look at figuring out the coordinates if it's not a quadrantal angle. All right, any questions on that? Okay. All right, so that's homework for tonight. So 11 to 27 odd and 22 on page 116. And you've got just under, you guys got 20 minutes. You got just about 20 minutes left. So you can use the time to work on that. And if you have any questions or need help with clarifying directions, just let me know.
Does the 22 there mean that we're doing question 22 as well?
Yeah.
Okay.
So it's 11 to 27 odd and number 22.